dicembre o di biglietto di corsa semplice e rimangono i giorni 17 e 18 dicembre.
So I was on my way to Rome. You know, beautiful buildings, statues, ice cream, pizza, and squares. And I was thinking, why not do a quick lesson on finding the area? The area is the number of square units inside a flat surface or shape. It's kind of like asking yourself, how much color will it take to cover in a shape? Rome, squares, area. Let's check it out. So I'm standing in front of the Colosseum, where the Romans used to have gladiators fight to the death. And all that crazy stuff. Oh, let's do something a little more exciting, like finding the area. We have a rectangle that is 2 feet by 5 feet. The 2 feet tells us we have 2 units down, and the 5 feet tells us we have 5 units across. If we put them together, we have 10 squares. So the area is 10 square feet. It doesn't matter what the measurement is. It could be feet, inches, centimeters, or yards. It could be anything. The 2 tells us we need to separate the rectangle into 2 pieces, and the 5 tells us we need to separate it into 5 pieces. When we combine them, we get 10 squares. The easiest way to find the area is to just draw the squares inside the figure and count them. Let's do a few more examples. This time, we have a 6-sided polygon, or a hexagon. The top is 7 centimeters, which means we need 7 squares going across. The left side is 3 centimeters, which means we need 3 squares going down. Knowing this, we can now fill in the top section of the shape. Now we can work on the bottom section. The left side is 2 centimeters, which means 2 squares down. And we can already see the 3 squares going across, so we can just fill in the rest. If we count the squares, we get 27 square centimeters. Let's try another one. This figure has 8 sides and is called an octagon. If we go around the shape, we can see all the squares needed to fill it in. 3 yards, 3 squares, 5 yards, 5 squares, 8 yards, 8 squares, 3 yards, 3 squares, 2 yards, 2 squares, and 4 yards, 4 squares. Now we can fill it in and count the total squares. This figure is 31 square yards. So, have you noticed a shortcut yet? If we go back and look at the first example, we knew we had to separate the rectangle into 5 sections across and 2 sections down, which gave us a total of 10 squares. So the shape is 2 by 5, or 2 times 5, which equals 10. So you can save yourself some time and multiply. If you forgot, or you didn't know, multiplication is a shortcut to addition. So if we're counting, why not multiply? Those are just simple quadrilaterals. What happens when the squares are not complete? Let's take a look. This is an isosceles triangle with a base of 5 miles and a height of 5 miles, which tells us we need to separate the base and height into 5 sections. We can clearly see 10 squares, but some of the other squares are cut in half. The best way to count these is to combine them to make one complete square. 2 halves make one whole, so if we combine 2 of the half squares, we will get 1 square. As you can see, we now have 2.5 more squares to add to the other 10 squares, which gives us an area of 12.5 square miles. See, we can still count, but sometimes the answers will not be perfect or exact. This triangle is a little harder. It has a base of 6 meters and a height of 8 meters, so we'll need to separate it into 6 sections going across and 8 sections going up. Again, we can easily see some of the squares inside the triangle, but some of the outside squares are not complete. Let's take away the grid lines and only look at the squares inside the triangle. If we look at the top section of the triangle, we can combine some of the pieces to make whole squares. This will give us about 3 more squares. Now we can look at the rest of the triangle. Let's combine these two, and then these, which gives us 2 more squares. And these two are almost whole, so let's just call them each 1 square. Finally, we have the 2 on the bottom left, and 2 more on the right, which we can combine to make 2 more complete squares. Count them up, and we get 23 square meters. But to tell you the truth, the actual area of this triangle is 24 square meters, so we're actually 1 meter off. In other words, you can always count the squares, but sometimes your answers will only be an estimate or an approximation. Let's do another example. This shape has 5 sides and is called a pentagon. The easiest way to solve it is to separate it into 2 different shapes. The first shape is a rectangle that is 3 millimeters by 5 millimeters, which gives us 15 squares. The second shape is a triangle that has a base of 3 millimeters and a height of 3 millimeters. Do you see where the 3 millimeters came from? Now count the squares and combine some of the incomplete squares. This gives us a total of 19.5 squares, which is actually the correct answer. So we talked about polygons, but will this counting the squares work with circles? A circle is a set of points on a flat surface that are the same distance from a given point. See how all these points are the same distance from the red point? The red point is called the center, and the blue line is called the radius. The radius tells us how far the points are from the center. Now, if we add more points, we'll eventually create a shape called a circle. If we connect 2 points on the circle and pass through the center, we create a line segment called the diameter. The diameter tells us how big the circle is, and it is 2 times the size of the radius, or the radius is half the diameter. So if we have a circle with a diameter of 7 feet, we know that it is 7 squares big. The easiest way to show this is to count 7 squares across and 7 squares up, which will create 2 diameters. We can now create a circle by connecting the line segments. To find the area, we do the same process as we did for triangles. We count the complete squares and join together the incomplete ones. With circles, our answers will always be estimates or approximations. Of course you can do circles. Let's do one last example. Let's find the area of a circle with a diameter of 10 centimeters. First draw 2 10-centimeter diameters, one going up and another going across. Do you see how they meet or intersect perfectly in the middle? Now draw the circle, connecting the endpoints of each line segment. We already know there are 10 squares up and 10 squares across. Now fill in the rest of the squares. Wow! 68 complete squares. But how about the ones we need to put together? By estimating, we can combine these to create complete squares. So the area is about 78 square centimeters. Remember, this is only an estimate or an approximation.
Let's go, team!
So today, you learned a simple way of finding the area of a shape. And it works on all shapes.
I'm just
But sometimes it's not perfect.
All you're doing,
But at least you can estimate the answer. Hope this helped. See you next time.